right, thank you. Let's hear it for Hans and Aaron. Shout out to Peter and Dan over there in the AV suite. Hey, guys. And JP, where's JP? There's JP. JP helped hook me up here, and he brought me some 4-barrel Guatemala beans, which actually is one of my favorites. I get something like this at Pete's. I never had it at 4-barrel, so I appreciate that, JP. Thanks. And I see some faces I recognize. I'll just point out for the mixer part, so you can grab these people and talk to them. There's Ito is here from Contendo, which is a really cool CDN with a lot of high performance features to it. And where's Josh? Josh, did you? Oh, there he is. There's Josh. He was working on his laptop, ignoring me, so he didn't hear me when I did the shout out. Josh is from Torbit, and they just relocated here from Boulder, and they are a web accelerator company. So you can grab him and talk to him at the break as well. And I don't know how well I'll do with these schedules. So this is a brand new talk, which is always kind of exciting. I hear all the talks that I give, and so they get pretty boring to me after a while. And someone got that. Great, thank you. And so it's good to mix them up. And there's some stuff I've used before in here, but a lot of new stuff. So let me dive in, and we'll see how the schedule goes. I think I'm going to run over on the Prezzo, but come in early on the Q&A. All right. So high performance mobile, you can see a URL for the slides down at the bottom, and to make it even easier, oh, here, I'll show you that in a minute. Okay, so this is my life. I take slow things and make them fast. I was at an O'Reilly meeting earlier last week, and you had to describe yourself in 3 words, and I said, make things faster. Or if you were to ask my wife, obsessive compulsive disorder. So like everything has to be really organized. I got coffee today at Google, and I was struck by how all the packets of sugar were incredibly aligned and optimally packed. We had 4 different kinds of sugar, and all of them were like, you could not have fit more sugar packets in those 4 containers. And it's like, yes, that's my life. That's why I love it at Google. So I make things faster. I worked at Yahoo for about 8 years. I started the exceptional performance team there. And I've been at Google about 3.5 years now, quite a bit of time. I do a lot of open source software. YSlow, I created Kazillion, SpriteMe, Hammerhead. You can look all of these up. BrowserScope, Lindsay's running that now. He's going to talk about that next week. JDrop I'll show today. HTTP Archive I'll show today. I wrote a couple books about performance that I think are good books, high performance websites. So that was 2007. It's more evergreen than I thought, but it's certainly out of date. I mean, it's not talking about browsers. You know, I don't need, maybe it's got IE8 in it, but it's still got a lot of good background, I think. Even Faster Websites is newer, talks more about Web 2.0. I taught high-performance websites at Stanford, and I co-chair the Velocity Conference. We just finished our 4th year, and we're rolling out Europe in November. I think I've got a slide promoting that in a minute. So yeah, I have that URL for these slides, because I'm going to cover a lot of information. At the end, I'll have this thing about takeaways. For me, like, I don't even want to get up and talk unless there's at least 3 or 5 things that you're going to go home and try when you get to work tomorrow. So I think having access to the slides is really important. I'm going to go really fast. There's going to be a lot of links. I have URLs in the slide deck, and you can always pull them up and look at them later. So if you go to my website, I have all my talks listed. You can go to previous talks by clicking on more, and I've got the slides for all of them. So you can go there and get the slides for this talk. And while I'm on my site, I wanted to plug my blog, which to me seems completely obvious that everyone should read my blog, but it turns out most people don't. And I'll talk about stuff and I'll say, oh yeah, did you read that blog post about how iPhone apps don't read anything from cache? No, really? Oh yeah, I blogged about that. So in fact, that's one of This is one, if you build, so I'm going to talk about open web technologies today for mobile. If you build a web app and you put it on the iPhone home screen, it won't read the resources from cache, even though you make them cacheable. So that's a really devastating and surprising finding. And so if these are the kind of things that interest you, I recommend subscribing to my blog. I try to get a lot of new stuff up there. Okay, preamble is over. So 4 parts of this talk. Part 1, WPO. So when I started the Exceptional Performance Group at Yahoo back around 2004, 2003, I'm sure there were other people working in the space, but when I Yahooed for it, that's the verb for searching on the web before Google, when I Yahooed for it, I couldn't find really anything about web performance. I found one article that I thought that I still think is amazing from David Hyatt, but that was about it. And so, I started developing these best practices and trying to evangelize those to development teams, and found it really hard. People weren't really aware of these. They thought most performance optimizations were on the back end, not the front end, and it was really hard to get traction with these best practices. So fast forward to last year, we have Fred Wilson, the top VC out of New York City, at Future of Web Apps, doing a talk about his 10 golden principles of successful web apps, and number 1 on his list is speed. First and foremost, we believe that speed is more than a feature. Speed is the most important feature. And so he goes on to talk about how all their portfolio companies are tracked by pingdom, and there's no doubt in his mind that when those companies' websites start degrading from a performance perspective, they drop off from a business perspective too. So that's why speed is number 1 on his list. So there are lots more case studies like this that have been presented at Velocity and other places over the last 2 years or so. So here's Bing talking about a 2-second slowdown is a 4% drop in revenue per user. Here's Google doing the same sort of thing. 400 milliseconds is a 0.6% drop in user engagement. For Yahoo, 400 milliseconds was a 5 to 9% drop in full page traffic. Mozilla shaved 2.2 seconds off the IE landing page, and their conversions went up 15%. Shopzilla made their website 4 seconds faster, and they saw a 7 to 12% lift in revenue. They doubled the number of unique users coming in from search engine marketing, and they cut the hardware requirements in half. Netflix turned on gzip. Don't ask me why they didn't have it turned on. They turned on gzip, and they cut their outbound traffic from their data centers in half. Anyone who pays the traffic bill for your data center knows that that's a lot of money to cut in half. And similarly, Edmunds.com turned on expires headers and e-tag headers and cut their CDN traffic by 1/3. So that's a lot of money savings as well. And about a year ago now, Google announced that site latency was going to be one of the factors in your quality score, which would affect your search ranking, which of course is important to people. So all of these things I saw all of these things kind of converging, and about a year ago I named them this new industry, Web Performance Optimization, or WPO, and I started whispering that around, and it's kind of stuck. There are a lot of these companies that call themselves WPO companies, and to me there's 4 basic wins here. It drives more traffic to your site if you make the site faster. It improves the user experience. We see that through these statistics about searches per user, time on site, page views per session. It increases your revenue. We saw stats supporting that, and it reduces your operating costs. So these are all great wins, and so we're getting better traction. And I think the important things about these, one of the important things about these case studies is it talks in a language beyond just code quality. I really love optimizing things from a quality perspective, but sometimes when you're trying to evangelize performance across your organization, you need to talk to people where engineering quality isn't necessarily the top thing on their priority list. And so I think when we talk about things like cutting operating costs and increasing revenue and getting more unique users through advertising, that can resonate with all different parts of the organization. So I think these case studies have been really important in driving adoption of WPO. Okay, so that's part 1. Part 2, I'm here talking about mobile. Why? So I announced earlier this year that I was going to try to switch all of my research focus to mobile. Really the thing that kicked that off was I got this nice MacBook Air from Google, and it enabled me to do some things that I'll show later more easily. But really the thing, I'd been thinking about it and wanting to make this switch of focus for about a year before I announced it. And that is pretty much solely motivated by these Mary Meeker slides. Mary Meeker was an analyst for Morgan Stanley, and now she's with a VC out here. I forget which one. So these are her slides from Web 2.0 Summit, I think 2010. And it's kind of hard to read. What she's talking about here, let's see, is that the video camera that where am I being video? Am I being video recorded? So if I like walk out of there, I'm going to be out of the view. Oh, really? Oh, okay. So we see here, Mary's using Netscape as a proxy for adoption of desktop internet. And after 11 quarters, there were about 18 million people on desktop internet. And after the same amount of time for mobile, we have 86 million users. So you can see that this hockey stick is growing much more than desktop presence did. And if you go to other mobile talks, you'll get a lot of stats about this. I think I just read an article today or yesterday about how there will be more people accessing the internet from mobile devices next year than from desktop PCs. So no doubt, I think everyone here would agree mobile is exploding. This was the thing that really caught my eye. So Rakuten.jp is a Asian website. It's kind of like Amazon. You can buy everything there, even groceries. And this was in 2010, right? No, 2009. In 2009, 18% of their e-commerce was done over mobile. And in Mary's prezzo, she mentions that the same stat for Amazon US for that year is 2%, right? And so again, like if you listen to some of these mobile talks, people talk about how Amazon, what was it, last year Amazon did $1 billion in mobile, which is, you know, pretty awesome. But then we have this study from the New York Times that says, yeah, sure, you know, mobile in the last quarter was 1.1 billion, last quarter of 2010, but only 2.6% of that was done on mobile. So we're still lagging. We know that US lags behind Asia in use of mobile, adoption of mobile. And we're seeing that here in the use of mobile for e-commerce. And so I believe in the next 2 years, we're going to see this order of magnitude increase in mobile e-commerce. And the sites that are going to capture that 10x increase are the sites that have a fast user experience. At least that's what I believe, but I'm not the only one. In our next slide, Mary says, these users are expecting near zero latency access to nearly all information for their mobile experience. So Mary and I think the same, and I'm very happy about that. I'll take that as a compliment. So huge business opportunity in mobile, right? So that's one reason why I really want to focus there. Here's another reason, is when I first started to evangelize desktop web performance, WPO, the players there, the vendors, the big publishers, really had to be convinced. I had to help bring them to the table with these case studies and A/B tests and things like that. But look at what we see from the big players in mobile. Here's an ad for iPhone 4, and the second word is fastest. Nexus S. Fast just got faster. It was already fast to begin with. Don't ever think of it as being slow. But now it's faster than fast, as the ER implies. AT&T speeds up to 4 times faster. It was already fast again, but now it's even faster. And Verizon, blazingly fast speeds, right? So I'm really excited about this. I think that performance speed is already being touted as a competitive advantage by the major players. And so I think it's going to be easier to get this adoption, this focus, this buy-in for web performance. And so I'm very excited about that. If it makes my job easier to see these best practices adopted, I love seeing that happen. And then here's the third thing why I got really excited, why I'm really excited about getting involved in mobile, is we have all different kinds of people using mobile, right? But, and they're in different geographic locations. They're using it for texting, for web navigation, for video, for talking. But across all of these users, what's the one thing they have in common? It's really slow. Who here is really satisfied with the speed of their mobile experience? Yeah. There's always one. As a what? Yeah, it's convenient. But how about like the responsiveness of it? Are you ever, even though it's illegal, are you ever like doing something in the car, like last minute you need to get directions, or you're on the way to the movie and you're not sure what time it is or which theater you're going to, and like, I don't know how many phones I've thrown out the window. Just, it is, luckily I get them for free, so I'm joking. As long as I'm joking, I'll go ahead and talk about this shot. So I did my first mobile talk about 3 months ago, and I needed a picture for the cover slide, and I spent like 2 hours on Flickr, and I couldn't find anything that I thought kind of captured mobile performance. And so I was coming back in the morning from working out, and I stepped across all these snails in the front yard. You can see it's 7:45 in the morning, and I grabbed one and brought it back and put it on my iPhone and took the picture of it. And while it started crawling across my phone, it activated edit mode. And it continued to crawl diagonally, and it deleted my Twitter app. And this was the day after the Twitter Dick Bar had launched, and there was all this outrage about Twitter. So when I did my talk, I told this joke about, and the snail doesn't like the Dick Bar either. So, But anyway, I think it's a good photo. And so I think in general, most of us are on that page. Like, sometimes it can be really, really frustrating at how slow the mobile experience is. How many people here, like you just went to that page this morning, whatever it was, Fandango or Amazon or whatever, and you go back to it this afternoon and it's like nothing is cached. It's like the page, and it's not like you've been watching YouTube videos or downloading, images all day. Like you looked at this morning and then you checked your Gmail, and then like 4 hours later you pull it out and you open Fandango again, and it like takes forever to load. It's like nothing. What is going on? Like to me, it's completely frustrating. Completely frustrating. So we have all of these things. Like there's huge business opportunity, right? The major players are already bought into it. They're touting performance as a competitive advantage, and everyone is frustrated about their experience, most everyone. So why is it that things are the way they are? So this is why I think it is the road isn't clear. And to be honest with you, like in the third part of this talk, I'm going to list some best practices, these kind of soundbite things, but it's a much bigger problem than that. I mean, right now, like the kind of status quo thing to do is write a whole new code base for your mobile app. And maybe it's not even a mobile web app. Maybe you have the decision to make about native versus mobile web, right? It's a really confusing problem. And the players in this space who are getting involved, Sencha and Strobe and jQuery Mobile, I mean, their products are pretty new. And the ways to use them to design your framework are pretty new. People are trying stuff out. Just today, like around us, new things are happening every day. So like, it's kind of not that surprising to me that things are pretty messed up right now. So what I hope to do along with these other people is share some things that I've learned. And I'm also at the end going to talk about tools. I think that's the original text on this slide was zero visibility, because up until about 4 months ago, it was pretty much impossible to tell what was going on your mobile phone. And luckily, we've had some advances there, and I'll do some live demos of those in a minute. OK, so let's move on to part 3. Doing great on time. So some of these soundbite best practices. OK, so people come in late, and then during the Q&A, they ask, are you going to put these slides online? So because they missed the slide at the very beginning that says all the slides are online. So if you came in late, all the slides are online, and you can find them right on my website right there where it says slides. Okay, sorry. Okay, mobile best practices, these little soundbite best practices. So people ask like, oh, well, you wrote these books, you know, is that still apply to mobile? And you know, most people said all of them apply, you know, yeah, all of those things apply. And I think in general they do. There are some things that don't apply. And I think the prioritization has changed. This is an interesting conversation to have with Josh because he's, you know, trying to automate this. How do we accelerate for the desktop, but also how do we accelerate for mobile? And the way that we do that, the logic behind that is likely to be different. And it turns out, yeah, it is. It should be very different. So here are the 14 rules from high-performance websites. That's kind of hard to read, but I've grayed out 2 of them that I think don't really apply to mobile. CSS expressions, you know, IE is kind of late to the game and non-existent, not that big of a player. I don't even know if CSS expressions work on Windows for mobile. And I think we at least have to question whether we should make JavaScript and CSS external. I was talking, and I'll talk more about how it seems like nothing's cached when I load a page. And so like the whole argument behind making them external is you get them in the cache, but if it seems like nothing's cached, then maybe that's not a good idea. And we'll talk more about that. So, you know, I don't think those are as applicable to mobile. And with some barely discernible yellow highlighting, maybe ones that we want to give a little higher priority to. Well, make fewer HTTP requests was already priority number 1. But that's, I think, really important. The latency on mobile devices and the connection speeds are very slow. Latency especially is really high. So as few HTTP requests as possible. DNS lookups, again, we were just talking about DNS a minute ago, eDNS. Latency can make this very painful. And again, because of latency, avoid redirects. There's actually more redirects in the mobile world than there is on desktop because, again, the way people are rolling out their mobile presence is like, oh, yeah, we'll go to www.fandango.com, and then I'll redirect you to m.fandango.com. And it's like, you know, I'm driving in my car, and I'm about, you know, the thing's halfway out the window, and you're sending me through a redirect. It's gone. So avoid redirects. Okay, and then here are the chapters from the second book, and you can see all the awesome folks that helped. Nicholas Zakis, geez, these rock stars that helped contribute to this book. So, you know, the only one I think that doesn't apply is sharding dominant domains, domain sharding. You know, that's where, how many people know what domain sharding is? Okay, so, well, here, let me just show this. So here's the, this is from BrowserScope, actually. This is what BrowserScope is all about, collecting, crowdsourcing information about different browsers. And it has like, I don't know what, thousands of browsers in it because we crowdsource all the data. Anyone on any phone or any desktop or any laptop or any netbook. On my, I've got Google TV. So I'm going on the Google TV browser and running it through the BrowserScope benchmarks, and it's showing up now in the results. So here's the results from BrowserScope about connections per host name and total connections, maximum connections that the browser will open. And we see pretty good green stuff up in the desktop world, right? Except for IE7, right? It only does 2 connections per host name. So let's suppose I've got 20 images. Do I want to request 20 images from www.mydomain.com? I'm sorry, I'm going to have to take the phone. This is actually part of the mobile demo. No, I'm joking. So, you know, if I have 20 images in IE7, if I request all of those on one domain, it's going to download 2, and then another 2, and another 2, and another 2, and so basically, it's going to just for those images, it's going to require 10 download phases, right? So domain sharding is, well, let me download them from www.1.mydomain.com, www.2. Maybe you want to use 2 to 4. So suppose I use 2. Now instead of 10 download phases, it's only 5 download phases. You basically cut the download time in half. So that's domain sharding. And so it's really good here. You could get in trouble doing too much domain sharding. If you just shard across 2 domains, you're probably not too bad with these guys because you're doing more DNS lookups and they're doing 6 per domain, so maybe you've got 12 connections going simultaneously. You've got a newer browser, maybe you've got a more high-powered client running, so maybe that's okay. But now here, the reason domain charting isn't so good down here is we see some numbers that look okay, they're both green, but then we see things like this. Only 5 max connections. So if I do that, suppose I shard across 4 domains, www1, 2, 3, 4. Well, it doesn't matter. I'm trying to download these 20 images. I'm doing 4 DNS lookups. I can still only download 5 at a time. And I'm also fighting with other things, ads and the main domain that the HTML comes from, and JavaScript probably comes from somewhere else. So you're doing all these DNS lookups, and you're not getting the parallelized download benefits of that. So as these browsers, you can see it's in an older Android. As these browsers fall away and the nice green ones come out, we might want to think about domain charting, but right now it's a little dangerous. And if you are going to think about it on mobile, I might do it based on the client. So those are those rules, and which ones would I highlight in a hardly discernible yellow? Splitting the initial payload and loading scripts without blocking. Whenever anyone says, oh, I would love to talk to you about my website, it's kind of slow, without even looking at it, I say, oh, it's JavaScript. It's always JavaScript. Not always. It's almost always JavaScript. So, I've got these stats and studies and blog posts. 75% of the JavaScript that sites download, they don't execute until after the onload event, if they ever execute it at all. So, but JavaScript takes a lot of time to download, like anything else, but blocks the page from rendering while it's being downloaded. Images don't do that, but JavaScript does, so it's painful to download. And on this tiny little client, on this tiny little device, it's going to be more painful to parse and execute 100K or 500K of JavaScript. So you've got to be even more careful about JavaScript on these mobile devices, right? So that's why I highlighted those. And there are techniques that I'll talk about in a minute for mitigating that pain. And what else? Really focusing on, kind of coupled with that, is how do we create a responsive web app? Ben and Dion wrote this chapter, and really talks a little bit about web workers. You might need web workers, maybe not. But it also talks about how we need to be cognizant of the fact that when JavaScript is running, it blocks the UI thread. And so you don't want to even download 500K of JavaScript in the background, because once it starts parsing and executing, the UI thread of that mobile app is going to be blocked. So tips about that. Of course, Nicholas talking about efficient JavaScript, optimizing images from Nicole and Stoyan. I'll talk a little bit about images in a minute. So that's kind of the old school performance tips. And I think most of them apply. I think some now have a little higher prioritization than we might have given them on the desktop, where latency is smaller and connection speeds are greater. But what things are not in these rule sets that I might focus on? I've got 5 things I want to focus on today. One is re-emphasizing reducing HTTP requests. And I did a talk about a month ago about high-performance HTML5, and there's a lot of overlap because a lot of these mobile devices, or at least the smartphones, have newer browsers, and so HTML5 is more widely supported. We don't have IE6 and IE7 pulling us down. So we can do the things that I talked about in 2007, sprites, data URIs, but we can do a lot of things in CSS3 to avoid having to download more images. Border radius, rounded corners is the obvious one. Box shadow, linear gradients, the transformations that you can do with CSS3 if you're doing things like that. And with Canvas and SVG, we can do some simple graphics and icons without having to download a file. So these techniques, if you can avoid HTTP requests by using these techniques, that's going to be a big win. So reduce HTTP requests. Responsive images. What do I mean by that? What do people think of these background? Again, like I spend all my time searching on Flickr for these awesome background images. I find that audiences love them. Hey, there we go. Yeah. And it's really tricky. Like there will be some other ones later. I don't know if any of them pass. But like I'm thinking like resize images, and I'm thinking like, what would capture that? Oh, the Russian dolls where they're all, So okay, resize images. So the idea is, I've got the photo of the day, and it's 600 by 400. I don't want that much data downloaded to my phone, right? Because it can't show a 600 by 400 pixel image. So you can reduce the download size by having images that are appropriate for the size of your device. How do you do that? That's kind of a big job. Actually, it's not that hard to get on it really easily. There's this service called Sencha.io source. And basically, you just take the URL of your image and you append it to source.sencha.io. And behind the scenes, this is what used to be called TinySource from James Pierce. James Pierce works at Sencha now. And he's also the creator of Device Atlas, which is this database that for different user agents knows the capabilities of those user agents, including screen size. And it's really fast. He's got a patent on this lookup algorithm. It like boils down to this tree search that's hugely efficient, and all of the data is less than, I forget, like 120K or something like that. It's amazing. And so he coupled Device Atlas, which can very quickly recognize what the screen size is for the current client, and then he coupled that with some image processing libraries on the back end, and will return a resized image that's appropriate for the device, right? So that's very cool. And if you want to do domain sharding, like if you're detecting those mobile devices or desktop clients that can support a lot of connections, then you can do domain sharding. They support that, source 1 through 4. So this is something like you could start using. I wouldn't maybe roll it out on a business website initially, but I would certainly try this out on a private website or smaller website. And there are other, people get very religious about UA sniffing, although I think doing it on the server side, a lot of people do that anyway. I'm fine with it, but there are these other techniques. One I just read about this week, adaptiveimages.com, and then the one from the Filament Group jQuery guys that are more, what they do is they run JavaScript on the client, detect the screen size, and then communicate that back to the server to negotiate the resize dimensions of the images. So doing this can save a lot of bandwidth, a lot of bytes that you're downloading for a website. So I think this is a really good technique to adopt for mobile. So then I talked about JavaScript. I want to talk about JavaScript a little bit more. So in HTML5, we have the async and defer attributes. And so the problem with scripts before was while a script is downloading, all rendering in the page is blocked, right? And other scripts are blocked from executing, right? So it can really hurt the user experience from a performance perspective. So you can use the async and defer attributes, right? So async basically says, start downloading it right now and execute it as soon as it arrives. But while you're waiting for it to download, go ahead and continue parsing the rest of the page and actually lay stuff out, right? The reason that browsers typically don't do that is the script might do document.write. And so if I'm laying out DOM elements and then a document.write happens, what am I supposed to do? Opera is the only browser that actually can handle that. All the other browsers can't handle that. And so basically, if you're saying async or defer, you're saying, I guarantee document.write is not used by these scripts. So async, we'll start downloading it now. We'll let the parser continue. And as soon as the script arrives, then it'll be executed. So like Google Analytics has an async snippet. That's a great example because it's a standalone script. As you know, you can it doesn't really affect the page. So you can let the page continue, and as soon as Google Analytics comes down, fire the logging beacon. And then defer is kind of similar, but what it says is don't execute it as soon as the script comes back. Execute the JavaScript after parsing is done, because depending on the size of the file, it could take a fair amount of time to parse and execute the script. And if it's really something that doesn't matter for the rendering of the page, let me render the entire HTML page before I start doing that parsing and executing. So those are very nice. One thing is, when is the script actually downloaded? So in most cases, in testing, it looks like it gets downloaded as soon as that script element is parsed, but the spec is kind of unclear about that. Or maybe a better word is obtuse. So let me read this quote from the spec that talks about this. Note, the exact processing details for these attributes are, for mostly historical reasons, somewhat non-trivial, involving a number of aspects of HTML. The implementation requirements are therefore by necessity scattered throughout the specification. The algorithms below in this section describe the core of this processing, but these algorithms reference and are referenced by the parsing rules for script start and end tags in HTML, in foreign content, and in XML, the rules for the document.write method, the handling of scripting, etc. Everyone got that? Is that clear? So, like, you don't really know what's happening. And to be honest with you, these async and defer really, they don't do it for me. What I really need are these two things. I want you to defer the download, because especially on those devices that only have 5 max connections, if this is a script that I can defer, if it's not painting anything in the page, I don't want you using up one of the 5 connections that could be used for an image for my logo or the photo of the day or a sprite for buttons or something like that. If I said defer this script, don't block the visible stuff in the page from being downloaded. But by downloading the script immediately, even when it's async or defer, you're using up those connections from the shared connection pool. So I want some tags that say defer the download and the execution until after parsing is done. And this is the one I really want for mobile. I want you to do the download in an async or defer way, so don't block the rest of the page. And I don't want you to ever parse and execute the script unless I ask you to. So I want you to execute on demand. So we had discussions and threads on this with the WhatWG group and just never got consensus on it. And so as a result, we're kind of hand-rolling solutions. So what are some of those hand-rolled solutions? Here's something Gmail Mobile did about a year ago that I blogged about. Have I mentioned you should read my blog? What they do is they download JavaScript in a script tag, and all the JavaScript is surrounded by comments, right? So this gets, so what you want for a mobile device is, if my connection is kind of slow, I don't want to click on some new feature like show me my address book, or I want to compose an email. I don't want to click on that and have the web app say, oh, I need that 100K of JavaScript. Let me go request it while you're waiting for this address book to pop up. Let me go request it and download it over this slow connection. What we want to do is we want to get that JavaScript on the device in the background, so it's ready if and when you activate that feature, right? Now the problem is, a lot of times these features are 100K or even more of JavaScript. And so if I download them in the background the normal way, then when the browser on the mobile device starts parsing and executing that big JavaScript payload, the UI blocks, right? And the user has no idea why. Something is happening in the background, and it's blocking the UI, and the user's clicking on buttons, and nothing's happening, right? And then eventually it will unlock the UI, and all those clicks will be heard, or maybe they won't be heard. And so what Gmail did was very cool, is they said, okay, well, in the background, we're going to download that 100K or whatever it is payload of JavaScript, but we're going to wrap it in comments. So it gets on the device, but it does not get parsed and executed. And then what you do is you access that script DOM element, and you get its text out, and you just remove those comment delimiters and eval the string. And now all of those, I see someone wincing with eval. I just had Josh and I just exchanged email about this. So I'll ask you to read Charles Jolly's micro benchmarks he did about a year and a half ago. Well, and Gmail's doing it, so. I don't know, I think, yeah. Okay, I won't say more. I'll get in trouble. I think this is really good, though. Okay, so So this is a great technique for prefetching JavaScript that may or may not be needed later. You get it on the device so that if the user does need it, it's right there, and then you can incur the parse and execute time, which kind of makes sense because now the user requested something, address book, and so the UI is blocked until that JavaScript is parsed and executed. It makes sense. It's in tune with their experience, as opposed to downloading stuff in the background that they really didn't activate, and it's blocking the UI thread. So that's a really good technique, and there's a URL, you can read about it. And then kind of based off that and some work Stoyan Stefanov did about downloading JavaScript without parsing and executing, I wrote this JavaScript library called Control.js. And what I wanted to do is I wanted to make it so that the whole thing could work asynchronously, but it could have this behavior of downloading without blocking anything else in the page and not executing anything until you were ready to do it. And the thing I kind of like about it is I think it's a pretty simple syntax. You just change the type and the source parameters of your script tags. It also works with inline scripts, which most of the other loader libraries don't, because a lot of the time you're downloading JavaScript and then you have an inline script tag that uses that JavaScript. And if you're downloading it asynchronously, you're going to get race conditions and have errors. So I actually wrote this mostly as a proof of concept, but it's gotten a fairly wide adoption. There are even big companies and big software tool companies using it. So it's pretty cool, and it's an easy syntax. Yeah, so here's what you can do. You can say CJS, Control.js execute equals false, and then later you can call CJS execute script, and it will do that eval of the JavaScript. And it doesn't use the comment technique. It's downloading it, the JavaScript as, oh no, actually in this case it's downloading it as scripts just with a different type. So this works across all browsers. So I think that's really important. So if you have a slow website, especially mobile web, look at JavaScript first. Okay, so then we talked about caching a little bit. I talked about caching a little bit. So here the background image is because you're offline when you're in the middle of a desert. See that? Yeah. So why am I talking about app cache in terms of caching? It's because caching really is terrible on browsers. So this is a study Tenny Toyer and I ran 5 years ago at Yahoo, where we put some resource in pages for various Yahoo properties, and then we tracked whether people had that in their cache or not, just by looking for 304 responses versus 200 responses. You can read more detail here. And basically, there's two stats that we tracked. How many page views came into that Yahoo property with an empty cache every day, and how many unique users came in at least once during that day with an empty cache. And what we see is about 20% of page views are done with an empty cache, but about 50% of users come in at least once a day with an empty cache. And I don't know about you, but that's much higher than I would have expected. And we ran this across different types of properties. And so it's not just, oh, there's a weird user dynamic in property X. We ran this across a variety of properties and saw basically all the same results. And so I can't explain why this is so low. Maybe users are clearing their cache. Maybe there's more antivirus software that's doing that. Maybe the caches are way too small. We've seen that. All the browsers have dramatically increased their cache sizes in the last 6 months or so. But for whatever reason, these are the stats. And I've talked to other people at big companies who have done similar experiments, and everyone gets the same results. So for your website, this is pretty much what your desktop users are experiencing. That was 5 years ago, so we weren't looking at mobile devices. But Blaze.io wrote this blog post about 3 months ago, where they found that for iPhones, there's no persistent cache. And if there's time at the end, we can look at this with a packet sniffer. Basically, If you power off your phone or stop the browser process, the cache is wiped. Now, I don't know, maybe not that many people stop the browser process or turn off their phone. I mostly only turn off my phone when I get on the airplane. I do close the browser processes quite frequently. If that happens, then there's no cache. Even if there is a cache, for Android and these Android devices, the persistent cache is only 4 meg, which is pretty small, right? So I think this is why we're not seeing a good cache experience on mobile devices. So that brings us back to app cache. It's great for offline. It's also a great way to get better caching out of your mobile web app. How does it work? You have to have the right doc type. You specify this manifest attribute to the HTML tag. And then you have to create this file, myapp.appcache or whatever you want to call it. It has to start with cache manifest. I added a comment with a revision number. You'll see in a minute why. You can have this cache section, which is basically telling the browser, these are the things I want you to cache so that if the user is offline, you read it from the cache without even touching the network. And then you have pages that should never be cached by app cache. You specify those in the network section. There's this fallback section, which is normally if they're online, I want you to go to index.html, but maybe index.html has a login form, and if they're offline, why am I showing them a login form? Because I can't authenticate them anyway. So the fallback is when you normally would go to index.html, if they're offline, go to offline.html. And that could be in the app cache and show them a front page that maybe had their most recent content there. And you have to serve this with content type text/cache manifest. So that doesn't sound too difficult, kind of difficult. I built a couple apps with app cache and found it mind-warpingly confusing. So a couple things I'll share about that. Any HTML document that has the manifest attribute is also, that HTML document is also going to be saved to app cache. Even if you don't list the HTML document, like maybe it's home.html, even if you don't list that home.html in the network, in the cache section, it's going to be cached anyway. That bit me. Yes. So I didn't, because I thought, well, I didn't specify it for the cache. Why would it be? And it turns out it's a default. If anything in the cache manifest 404s, nothing is saved to the app cache. Just FYI, the size is about 5 megabytes. Like that's a minimum. Or there are some devices that are much higher than that. This is the point for that comment. So suppose I change something. I change a script, a style sheet, an image, and I want users of my mobile web app to get that new content. You have to rev the manifest file. You have to change something. So to me, the easiest thing is I put something like the CVS or SVN revision number in there. Or I just put something else that I manually edit so that the manifest file changes, the browser will download it, and it will check all the things and do a if modified since request, and it will see, oh, the style sheet has changed. Let me download it and put it into app cache. So that all sounds kind of good. But that's really tricky. You got to remember that. You're editing your JavaScript, you save it, you reload it on your mobile thing, and it doesn't work. And you're like, oh, I forgot to rev the manifest file. So then you have to rev the manifest file. But it turns out, even when you do that, users won't see that modified content until the second time they load the app. Okay, why is that? This one requires a separate breakout cartoon. Okay, you push your mobile app that uses app cache. It has a logo in it, right? And it's this green blob thing. Now the user, so you push your thing to your server, and now the first user goes to it. They load the app. The app cache is empty for your app because the user's never been there before. The user's mobile browser sees the manifest attribute and downloads that manifest file. The manifest file contains logo.gif in the cache section, so it gets downloaded, and it's saved to app cache, and it's green. And then the app is displayed to the user, and the user sees this green logo, right? That all makes perfect sense. Now it gets funky. Okay, you change. I want an orange logo now, right? So I update the logo file. I remembered I've got to change, I got to tweak the manifest file. So I tweak the manifest file. Now the user, after I do this push, the user goes to it, right? What happens? App cache right now contains the green logo, and the whole point of app cache is to load the app from the device. And so whatever it has in app cache, it's going to display to the user, even though there's a new logo out there. So it displays the green logo to the user, right? And now in the background, the browser checks the manifest file, sees that it got tweaked, downloads the manifest file, checks logo.gif, sees that it's modified, downloads it, and saves it to app cache. And now the second time the user loads the app cache contains the new logo that's orange, and the user sees the orange logo. In the background, the browser fetches the manifest file, and it hasn't changed, so it's a 304 not modified response, and everyone's happy. And the user, the second time they've loaded the app, sees the changes. This was hugely confusing to me. And any questions about this? Hopefully this explains it. So it's hard, yeah? Yeah. It would happen right where it fetches the logo.gif in step 4. It fetches the logo and anything else that's in app cache for this page, which includes the page itself. So the point of app cache is it's supposed to be like a native app. It's supposed to be able to load the entire app to the user without touching the network. And even if you're online, that's what it's going to do, right? And then if you are online, in the background, it's going to check for new stuff, download it for the next time the user goes there. So I find this really confusing. If you don't like this, there's a workaround to it. I've got some URLs to it here, and I'm starting to run out of time. So I'm going to try to go a little faster. But you can basically look for this update ready event listener, and you could trap it and do something like prompt the user if they want to reload the page, if it was something important that changed. Local storage. So again, another way to get around the weak browser cache, mobile browser cache. Excuse me, you could use local storage, very simple API, set item, get item, remove item, clear. The one thing that's missing is you don't have any way of seeing how much space is available. So suppose you want to save the user's recipes, and you try to save 2 meg of recipes, and there's only 1 meg left, you're going to get an error. So then what do? Well, you try to save 1.5 meg, 1.2 meg. And you just have to keep saving until it actually doesn't throw an error. So if you could query and you could say how much space is available, oh, I got an error, how much space is available? 800K. Okay, now I'll save 800K of recipes. That's better than nothing. That API doesn't exist. This is the way, I did this blog post, this is the way Bing and Google Search use it, is use local storage when you're on a mobile device. Is the first time you download a search results page, like suppose you just bought the phone, the first time you do a search on Bing, it's going to download a page that has all of these script blocks in it, like 50 script blocks. And it writes, after the page is loaded, it writes each script block into local storage. So you'll see a key in local storage like this, Jux UX base controls, that must be the name of the module, some hashtag or time or I don't know what, and then the actual JavaScript of that block. Now, it also sets a cookie that has that module, UX base controls, and the hashtag. So the next time you go to the Bing search server, it can look at the cookie and it can say, oh, this user already has UX base controls version 252 in local storage, so I don't have to return that in the search results HTML document. So the HTML document goes from about 120K to 9K. And all of those scripts and CSS blocks are read out of local storage. And hopefully I'll have time to, we'll actually do a live packet sniff thing and look at Google's solution. And so those were the 5 things I wanted to talk about. There's a lot more audio, video tags, WebSockets. Could be kind of interesting. People are doing, okay, anyway. Use on-touch-end instead of on-click. The history is going to save downloading a bunch of history JavaScript that you had to do before. A-ping will stop you from having to do redirects if you're trying to track where people are going. If you're doing animations with JavaScript, don't use timers. So I'm not going to talk about any of those. Oh, and use the native JSON parser. And these are people who, the most important person to follow their blog is me. But then after me, it's these people. So these are all the people that helped me with this talk and the HTML5 talk. OK, mobile tools. OK, so now if we have time, I think I am running over. I want to do what I think is really the most important takeaway for tonight, is this the road is not clear, zero visibility thing. So I'm so excited about this work that's been going on. It's really kind of painful to use, and you'll see that. But it's this PCAP perf project. I'm going to show that. And then this thing that I built, JDrop, along with a bunch of bookmarklets. So let me get out of that. And I'm going to go to a browser. And OK. I've never done this before. Live. OK. So I'm on a Mac. It's easier to set this up with a Mac than a Windows laptop. And so that's why I started getting into this. I've brought a, I'm on wireless for my laptop. So I want to start a Wi-Fi hotspot and connect to it with my phone so I can watch what my phone is doing over the network. Now, if I have a wired connection to my laptop, I can start a hotspot over Wi-Fi. In this case, when I first came here, I had a wireless connection to my laptop, so I had to use the Ethernet port to create the hotspot. So I always carry a Wi-Fi router with me. So I've configured the Wi-Fi router on USB Ethernet 2 with these settings, and I'm sharing it. So now, if we go here, let me just do one more thing. OK, so now what I'm going to do is I have this little shell helper function called TCP trace, which basically just runs TCP dump on the correct interface. I know the correct interface. If I do if config, I did this before I hooked up the wireless router. EN3 wasn't there. It's usually EN3. So now I'm going to start TCP dump. Oh, that's really bad. OK. Huh, that's funny. OK, here, hold on. Oh, this part doesn't matter anyway. So basically, I'm running TCP dump on the laptop. I'm going to start that going. OK, that's running. Now, and I've never used an Elmo before, so we're going to do that. OK, so this is this page. I've used this for years. It has nothing in it. So I'm always trying to load pages in between that are, just to break. Anyway, you'll see. So we'll load this. OK, so we're in here. We're TCP dumping. I'm going to reload this. I'm going to do a Google search for starfish. And I'll just mention, before I did this, I cleared local storage. OK, so there's starfish. Now I'm going to go back. And I'm going to load that fast Steve Souders page again. I think it just read it from memory, so I'm going to reload it. And now I'm going to do that starfish hit the second time. Because remember, I explained how the first time you do it, it downloads all the blocks and stuffs in the local storage. It's like 120 meg. The second time, it's only like 20 meg. OK, so now we did that again. So now I'm going to go over here. And one thing we could do is, I talked about JDrop. JDrop is this kind of JSON in the cloud service. And it's really, I built it to work with bookmarklets. Because bookmarklets run on every mobile device that I've played with. So I wrote a bunch of bookmarklets. I gathered other ones. So I wrote this Uber bookmarklet called Mobile Perf. You can get it on my website. It's on the front page. And it contains links to Firebug Lite. I wrote page resources, doc source, DOM monsters from Thomas Fuchs. Storager I wrote. There's a YSlow version of YSlow as a bookmarklet, so you can run YSlow on your mobile pages and these other things. So Storager is the one that lets us look at local storage. So let me open Storager. And if we open this, we see all these keys that have been written into local storage. And sure enough, if we look, there's some style blocks, some script blocks. This looks a little different because on the slides I showed Bing, this is Google working. But you can see this is pretty hard to work with, right? And you can see there's 195 entries have been written to local storage, sorry. So instead, I can click on this Save to JDrop. And so I have this very simple API, and I encourage anyone who's got a performance-related bookmarklet to integrate this Save to JDrop. You just put your data, whatever the bookmarklet is showing to the user, just put it in a JSON structure and use my API to save it to JDrop. Before I started the demo, I logged into JDrop. So on this phone, I'm logged into JDrop. So when it saved this data, it saved it in my account. So it tells me success, you just saved it. Okay, so now I'm going to switch back over here, and I'm going to go to JDrop. And what we see is, sure enough, 2009, that was a minute ago, Storager is the app that saved this local storage information, and I can look at it on my desktop, where it's much easier to look at, right? So with JDrop, you can get this information off the phone onto your desktop or into the cloud, and that includes YSlow information, DOM monster information, what's in local storage, what resources are loaded in the page, document source, all of that you can get up into the cloud, you can share it with other people, and you can view it on a screen that has more real estate. So what do we see here? So we see like this one. We see that there's a script block that was saved to local storage, and it's got YDUQ in it. So now what I'm going to do is I'm going to open pcap_perf. That was the other tool I was talking about. And what I did with TCP dump was I created a packet capture file, a pcap file, right? And now I can open that file. And upload it. And what this does is it converts the pcap file into a HAR file, which is an industry standard format that myself and Janet Varco and Simon Perkins created about 2 years ago. And Janet Varco, Hansa, is the guy who wrote Firebug's NetPanel. So he also took that JavaScript code for displaying Firebug's NetPanel and had it as a standalone module that works with HAR files. So now this pcap_perf uses his open source code, and what we see is, if you remember, we started by loading stevesouders.com. You can go over here and you can do this thing where you break the timeline. Okay, so now we did the first Google search, and then somewhere down here we did fast.stevesouders again, and then we did another search, which is probably this one. And you can see that here we had a little search that was 12.5K, then 96K, and this one's only 11K, right? And I want to look at this a little bit more. So you can see it's a little bit painful, but this is so incredibly powerful. So what we have here is this is the 96K response. Most likely, this is the one that has all of those blocks of JavaScript and CSS in it. So I'm going to look at the response, and I'm going to search for YDUQ. And sure enough, what do I see? Can you guys see that? It's a little visible. I see script ID equals, and it's got that long string that was in the local storage key. And so sure enough, we can see that the main page is downloading all of these blocks, and each of the style blocks and script blocks are given an ID. And my guess is the JavaScript in the code after the page loads goes through all those script and style blocks, gets their inner HTML or inner text, and saves them to local storage, right? And also sets the cookie. So how can we try to verify that? Let's go up here, and let's go down to this second response that was so much smaller. So first of all, we can look at the cookies going up. Look for YDUQ, and sure enough, there's a cookie going up to the server on the second search that's telling the server, I've got that YDUQ module in my local storage, and here's the checksum or something with it in case it changed, right? If I have something in local storage and it changed, the server can say, okay, I'll send you the new version of that block and we'll save it again. But in this case, it's all cool. And if we look at the response, instead of that long script with ID YDUQ, we've got a very tiny script block with a function _res, probably means resource, with the name to read out of local storage. So this is how that response, that search results page, dropped from 100K to 10K by using local storage. There are a couple other cool things in here that I wanted to point out. Remember I mentioned reducing HTTP requests by using data URIs. Whoops, here, let me look at the response. Here's the response in that first 96K response. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. There's about 50 images encoded in here as data URIs, only for the mobile Google search results page. So they're using that technique as well. And, oh, and then there was this quandary that had me puzzled for a little bit. Why is there a 12K response followed by a 96K response? I couldn't figure this out. And then I thought about it. What I do is I clear the local storage right before I do this demo. And here's the code that's dealing with this situation where what's happened is it's trying to do this fancy stuff, and it tries to read from local storage what is supposed to be there because this cookie went up. I didn't clear my cookies. I just cleared local storage. So I've done this like 5 times today getting ready for tonight. So my cookie says I have that module, and actually I don't because I manually cleared it out. So the code says, oh, I tried to read that module, it failed. So instead, I'm going to clear the mres cookie and reload the page. And now when that mres cookie gets cleared, and it goes to the server doesn't see the mres cookie, the list of all the resources I have in local storage, and so it sends back the entire 96K. Okay, that was kind of deep and complicated, but this is really, really, really cool. We can now see what's going on our mobile devices, at least to a certain degree. Yeah. Yeah, because I want to see what's going on the phone, right? Okay. So the question is, this local storage thing seems like a really awesome idea. How come Google Search only does it on mobile? I think that's a really good question. And that's something I'm going to get into in the next version of this talk is, I think it's a mistake, Josh, maybe if you're listening, I think it's a mistake to think about best practices for desktop versus best practices for mobile. It's really, the matrix is much more fine-grained than that. There might be some desktop browsers that don't support local storage. There might be some mobile browsers where I do want to do domain sharding. There might be some desktop browsers where I don't want to do domain sharding. So I really think what we're going to get to is we're going to get to this really fine-tuned performance application of performance optimizations. And right now, like the caching on the desktop browser isn't as bad as mobile. So the first focus, my guess is, the first focus for this local storage workaround was on mobile because that's where the caching is the worst. Okay, so I think I better hurry and get back on track. Okay, and I'm almost done. So that was JDrop. Please use JDrop. There's also this service that's very awesome from Blaze, where they have iPhones and Androids connected to their web server, and you just type in a URL, and they run it for you and capture the waterfall chart. The downside of that is, like, I tried to do this thing with Google Search, and their iPhones are in Ottawa, and Google hasn't released this local storage thing, and so it redirects me to google.ca, and google.ca doesn't have that code. So, but you know, that's a quirk. Most of the time, like, it's really awesome to be able to do this. You don't even need an iPhone or Android to get waterfall charts from mobile devices. Winery is a remote debugger, and it works very cool across. That's another thing, is this PCAP, perf, and JDrop stuff works across all phones. Winery is a remote debugger, works across all phones. I don't have time to show that. Okay, so I said I was focused on takeaways. What are the takeaways? So I actually covered quite a wide range of stuff here. I did start off with some marketing stuff and ended up with that TCP dump PCAP file stuff. So speed, you know, at the high level, marketing level, speed matters. Web performance optimization drives more traffic, better user experience, increases revenue, decreases operating costs. There's a lot of opportunity in the mobile space, and the people who are going to capture that are the ones that have a fast experience. The 5 techniques I really touted were reducing the number of HTTP requests, resizing images, making sure you get your JavaScript out of the way, using app cache and local storage, and the tools PCAP, perf, JDrop, Blaze, and Winery. I got a couple other things I want to do. This is my rockstar picture. I'm very embarrassed every time I open the website, but we're doing Velocity Europe for the first time. If you have companies over there, or you're going to be over there November 8th and 9th in Berlin, and we'll probably have some kind of like a meetup day the day before that, November 7th. And my main project these days is this thing called the HTTP archive. How many people have heard of it? Awesome. So I'm basically recording all this performance information about the internet. And I also have, working with Blaze, have a mobile version of that, although it's only covering about 1,000 sites right now. But you can go in and you can see things like on the desktop for the top 100 websites, the total download size is 490K, whereas on mobile it's 311. This is kind of interesting. The average HTML document on desktop is 28K, and on mobile it's 63K. So maybe, well, it sounds funny, but actually it might be a good thing where they're putting those data URI images in there, and maybe they're using these local storage hacks. But I haven't investigated that. All of the data is available to be downloaded. So my goal is really to just start capturing all that data and turn it over to people like you to investigate it and see, are they doing smart things or not so smart things? And you can see, of course, the size and number of requests always goes up. And then the last thing I wanted to say is I didn't talk much about native apps, and in fact, that's really not going to be an area that I'm going to investigate at all. And I can understand that there's a lot of motivation around building native apps, and the experience can be very good, and to be honest, can be maybe a lot better than what we can do with the open web right now on mobile. But I'm very excited about open standards, open tools, open technologies, and so that's really going to be the focus for my work going forward, in the past and going forward. And it is more challenging, but I think we're going to have a better future if we can make this the preferred development platform. And so I really encourage all of us to try to learn these best practices, learn from each other, share what we know, and make the open web stack the preferred stack for mobile development. And that's it. Thank you very much. So I apologize, Aaron. I went way over. I thought the demo was really important to do, and so I'll do questions for as long as we can. 5 minutes? Yeah. The question is, have I considered making my lectures available on the internet? Yeah, so You're going to be really sorry you asked that. Um, so, I taught that Stanford course, and so you have to pay money, but you can actually, if you click on this, you can get about 30 hours of video of me talking about this stuff on there. And then I have other videos and all of my talks. If you go to my to the More page, I've got the slides from all my talks, and many videos are available as well. And like I said, all the stuff I do is open source, and I write blog about it. So yeah, please do consume it. Yes.
So you talked about how Davis and Johnson using you do cover SSL handshakes. Talk about them, so I'd like to know what your thoughts are.
So the question was, I guess, mostly in terms of mobile or just in general about SSL?
Well, in terms of mobile, although I'm sure it depends.
Yeah. So what about SSL traffic in terms of performance? Yeah, SSL is slower typically. It turns out that a lot of that is just in the way that SSL has been implemented. Some of the encryption algorithms could be 10x faster, and it's just old code. But there are some other things we can do. For example, Google has deployed and submitted to the IETF some changes to the SSL handshake to cut out 1 or 2 round trips. In that negotiation, Eric Lawrence from the IE team wrote a great blog post about 3 months ago where he finds that most people close their SSL connections. They send a connection close response header, and that's like the worst thing you could do because it takes so long to set those connections up. So there are things we can do for SSL, but yeah, right now with the technologies we have, especially if you don't do the new IETF thing, it's going to be slower. Yes, Ido. That was Ido. Do you have business cards with you? Come find him afterwards. Okay, next, but right here first. The question is, have I looked much at how tablet performance compares to phones? And it's closer to phones. The screen size is closer to desktops, but the actual, performance, the power of the device, and the parameters that we looked at, like the number of connections and stuff like that, for the tablet browsers are about the same as the smartphone browsers. So really what you want to deliver is a visual experience that's closer to the desktop, but when you look at how you're building that, you want to think more like a phone. Okay, and right here, yeah. Yeah, so the gentleman was pointing out that possibly we're seeing such a high number of unique users with an empty cache every day because IT is configuring the browsers when you shut down to clear the cache. Maybe, to be honest with you, it's because the caches are too small and the purging algorithms are poor. So, I've had meetings with pretty much all the browser vendors, and like I said, about 6 months ago, they dramatically increased the sizes of their cache. And the other thing that we saw first with IE, and I think Chrome is working on it as well, they might have released it, is better purging logic. And so we see that we know, for example, I talked about before that downloading a script is much more painful on the user experience than an image. And yet, if I have a 50K script and a 50K image, I need to purge something from cache, they're treated equally. So really what I suggest, and we're finally seeing a couple of browsers pay attention to this, is in incorporating MIME type considerations in the purging algorithms. And so in fact, IE has a new purging algorithm gives JavaScript a higher priority to remain in the cache. So I think if we increase the sizes, we change the purging logic so spending 3 hours on YouTube doesn't cause something you use every day, Gmail or Yahoo Calendar, to be purged from your cache. We'll get better caching statistics. But that certainly is a part of it. Yes? Yeah, so I differentiate. The question is, Minify.js, is that done with the Clojure compiler? Yeah, you can do that. You can use JSMin. Yahoo, I forget what their solution is. There's several solutions out there. Some solutions work for, like Yahoo's solution works for both JavaScript and CSS. Some only work for one or the other. But I distinguish between minification and obfuscation. So minification is just get rid of the white space. And obfuscation is I have a really long JavaScript function name or variable name. Let me change it to something that's shorter. And you certainly get better results with obfuscation. But after gzip, I found the results were, I forget, in the book I did some studies, like 3% more or something like that. And I definitely saw major properties launch with bugs because they obfuscated their code and they forgot to protect their globals or public APIs. So, obfuscation is better. Unless you really are on top of it, like I just would say minify your JavaScript code. Yeah. So the first comment was about, I didn't talk about video. I don't know anything about video, to be honest with you. Like, there was a good talk, two YouTube guys I thought did an entertaining talk at Velocity in June. One of them is responsible for the Flash player in YouTube, and the other one is responsible for the video tag solution in YouTube. And so they kind of, had this back and forth at each other, kind of simulated catfight. And the basic conclusion was Flash is slower to start up, but in some ways is faster. Video in general will perform faster than Flash, but video has very low adoption right now. So as far as the video tag, if that's what you were talking about, it does show some promise, but it doesn't have much adoption right now. But I'm just echoing what they talked about. So you could. I can send you a link to that if anyone contacts me. And then the second question was about network operators deploying optimizations. And in some cases, if you do some of these best practices and the network operators do some optimizations, things overall might get better, or in some cases, they might break. Was that kind of the question? Yeah, so it's kind of interesting. Like, there's two ways that I view this, evangelizing a faster internet. And to be honest, like let's just be honest for a second. The whole reason that I do that, to evangelize a faster internet, is just to reduce my level of frustration. And so I just want all of you to. I'll tell you the sites I use the most, and if you could optimize those, that would be great. But to get to this evangelizing a faster web. There's two ways that we're approaching it. One way is my kind of bottom-up way, which I really enjoy, is going out and talking. I want to talk to all 500,000 web developers in the world, and I want to make them aware of this stuff and convince them that it's the right way to do things. And in reality, like if I actually reach 1% of those, that will be pretty amazing. But there's this bottom-up approach of evangelizing to all of the developers out there in the world. And then there's this top-down approach, which a lot of the Google projects and other bigger projects are doing, where we're going to change IETF standards. We're going to get CDNs like Contendo to have better best practices. We're going to get eDNS deployed. The browsers are huge. If we can get, there's been tremendous progress in the browsers. And let's face it, like when you go to the web, you go through a browser. So like if we can get the browsers to be better, that's a huge conduit. And by optimizing that major conduit, we can impact a lot of users. And also, we don't have to get people who own websites to actually do anything. Just the browser is faster, so their website will be faster. And there are times where evangelizing these bottom-up best practices conflict with the top-down. The only example I can think of off the top of my head is I evangelize a lot of this funky JavaScript hackery to get JavaScript to load asynchronously, and that caused huge headaches to the guy at Google who tried to make Google AdSense load asynchronously. Because if we're trying to load Google AdSense JavaScript asynchronously, but the person already is loading it asynchronously, we're doing like a double asynchronous, and then there's race conditions, and he would come up with a solution, and then me or someone else, Lab.js, would have a new way of loading stuff asynchronously, and it would break. And so there are times when doing some of these, especially like shortcut non-standard hacks can conflict when we get the top-down right way to do it. And I'm just kind of impatient. And I'm like, if it's a big win, you know, I recommend you do it, and hopefully people will go back and retrofit it if it has to be changed later. Yeah, in the back. No, I actually am not involved in that at all. I actually didn't know it launched until the day it launched. I had some pre-meetings with those people to just kind of talk about the concept and how, you know, people might react to it and things that would be important and not so important. I know that, I guess I'll say this, I know that the initial results were mixed. When I ran it on my own website, it was like they published like 4 time measurements, and like it was better in 3 and worse in 1. And when I read comments, other people kind of had similar kind of mixed experiences. But the one thing I would say about that is it's an initial launch. Like, they're not going to launch it and then not touch it again for 5 years. It's going to get better and better and better. And you know, I think Google has shown that it cares a lot about performance, and it does pretty good work. So I would expect it to get better. But as far as the actual data, yeah, I don't look at that. Yes, in the way back. Yeah, I did talk last month at the San Francisco HTML5 meetup group, and those slides are on my website as well. And yeah, you know, HTML5 has some things, you know, a lot of things that will be good for performance, some things that are bad for performance, and some things that are just kind of neutral. But that's kind of a long topic that I don't think we have time to get into right now. Yeah. The effectiveness of GWT, GWT? No, I haven't looked at GWT. No. And so maybe last one, yeah. It's got to be really, really awesome question. A lot of pressure. Well, I think the URL should be the same, and I think especially, you know, as we get this, you know, mishmash of devices, TV, tablets, phones, smartphones, feature phones, desktop, weak desktop clients, strong desktop clients. Like, you can't have a separate landing site for every one of those, right? And so I think you have to me, like, I would get all of the code to work, you know, through one entry point. And, you know, technically, like with Apache, you can use rewrite rules or whatever to get people to go to kind of a different code path without sending them through a redirect. And that sounds kind of easy to say. I know it's more complicated when you've got like a legacy team and a new team. But yeah, sending users to a redirect mobile users is a really bad idea. So try to avoid that any way you can. Okay, I think I'm going to wrap it there. All right, thank you very much.